Imagine holding your breath as a billion-euro spacecraft wakes from a decade of silence, or watching a fragile probe dive into the sun's atmosphere, knowing there's no way to steer it home. Picture the trembling hands of engineers who have spent half their lives building a telescope, only to see its first images bring them to tears. These are not just machines, they are extensions of human hope, courage, and curiosity. They carry the fingerprints of thousands who refused to give up, even when the odds were merciless. From the James Webb's golden eye gazing back to the dawn of time, to Parker Solar Probe's blistering dance with the sun, to Voyager's lonely sprint beyond the edge of our solar system, to Hubble's miraculous comeback, and Rosetta's daring kiss on a comet. Each mission is a heartbeat in the story of us. This is the chronicle of how humanity reached further than ever before, and discovered that the universe is not just out there, it's within us. Welcome back to Beyond Space. Where we explore the universe one mind-blowing idea at a time. Today, we're diving deep into the mind-blowing truth about Earth's journey through the galaxy. It began as a dream whispered across decades, a dream so vast it had to be folded to fit inside a rocket. For years, scientists from every corner of the globe poured their lives into building the largest space telescope humanity had ever dared to launch. At its heart, a mirror 6.5 meters wide, gleaming like a cosmic jewel, bigger than most houses on Earth. Too immense to ride into space whole, it folded in on itself like a delicate origami masterpiece, waiting to unfurl among the stars. The craftsmanship was beyond imagination. If this mirror was stretched to the size of the United States, its tallest imperfection would be no more than a single centimeter. That perfection matters because James Webb doesn't just look, it sees in wavelengths invisible to human eyes. In the deep infrared, it peers through cosmic dust, unveiling the atmospheres of distant exoplanets, the birth cries of stars, and molecules that whisper of life. Among its instruments, one almost didn't make the journey, MIRI, the mid-infrared camera. Without it, Webb could never have reached so far back in time or pierced the coldest, dustiest corners of the universe. Its inclusion was a triumph of persistence, a reminder that even in science, courage decides the future. Then came Christmas Day, 2021. In living rooms and control centers, scientists sat frozen, pillows clutched, hearts pounding. The countdown, the roar, the ascent, and then perfection. Webb unfolded flawlessly, a golden eye opening to eternity. The first images stunned the world. The Southern Ring Nebula revealing a hidden binary star, Stephan's quintet showing a black hole feasting in a galactic collision. Galaxies so distant, their light began its journey billions of years before Earth existed. And this is only the beginning. Webb is already rewriting astronomy, answering questions we've carried for generations, and sparking ones we never knew to ask. For astro lovers, it is more than a telescope. It is a time machine, a truth finder, and a promise that the universe still holds wonders beyond our wildest dreams. For more than 60 years, it was a dream too dangerous to chase, to send a spacecraft into the very heart of our star. The sun, giver of life and destroyer of worlds, has always been close enough to warm our skin, yet far too fierce to touch. Until now. The Parker Solar Probe is humanity's first emissary to the sun's doorstep. Its armor, a heat shield just 4.5 inches thick, a carbon-carbon and carbon foam sandwich that laughs in the face of 1,400 degrees Celsius fury. On one side, metal glows white-hot. On the other, delicate instruments hum along at a comfortable room temperature, as if they were still back on Earth. There is no joystick, no human hand guiding it. Parker flies alone, its sensors acting as instincts, detecting the slightest misalignment and correcting course in an instant. In space, hesitation means death, and Parker has none. August 2018. The launch was more than a technical milestone. It was a goodbye. Engineers who had spent a decade building her watched with separation anxiety as their creation vanished into the sky, knowing she would never return. To reach the sun, Parker didn't charge straight in, it danced. Using Venus as a cosmic slingshot, it curved closer and closer to its target, each pass tightening the spiral. And then, In April 2021, history bent. Parker crossed into the sun's corona, the shimmering outer atmosphere no human-made object had ever entered. What it found was astonishing. Magnetic switchbacks, sudden flips in the sun's magnetic field, carrying bursts of energy that may finally explain how the solar wind is born and accelerated. That wind, invisible yet relentless, races across the solar system at over 1 million miles per hour, shaping climates, disrupting satellites, and once plunging an entire Canadian province into darkness. Parker's journey is far from over. Each orbit brings it closer. Each discovery rewrites the textbooks of solar physics. And for astro lovers, it is more than a mission. It is proof that even the most impossible dreams can be reached if you dare to fly straight into the fire. In 1977, 2 small spacecraft left Earth, not to return, but to carry our curiosity to the edge of forever. Their timing was no accident. A rare planetary alignment, occurring only once every 175 years, allowed them to slingshot from one giant world to the next, using gravity itself as a free ride deeper into the solar system. Voyager 1 and Voyager 2 began their tour with Jupiter, revealing a planet far more turbulent than the serene disk seen through telescopes. They captured hundreds of raging hurricanes, glowing auroras at the poles, and even 3 faint rings no one knew existed. Saturn came next, its rings once thought to be few in number. Voyager showed there were more than 100, each a delicate structure of ice and dust. Voyager 2 then took the scenic route, visiting Uranus in 1986 and Neptune in 1989, where it discovered geysers erupting from the icy surface of Triton, Neptune's largest moon. Before leaving the planetary stage, Voyager 1 turned its camera homeward at Carl Sagan's request, capturing the pale blue dot, Earth as a single pixel suspended in a sunbeam. On that tiny speck, every human who ever lived, loved, fought and dreamed existed. The missions then pressed on toward the unknown. In 2012, Voyager 1 crossed the boundary into interstellar space, where the sun's influence fades and the winds of other stars begin. Voyager 2 followed in 2018, confirming that the solar system's protective bubble, the heliosphere, is not smooth and round, but shaped like a strange 2-horned comet tail. These explorers are fragile. Built with 1970s technology, each has only 5 instruments still running, sending whispers of data across billions of kilometers. Their signals are so faint, they arrive weaker than the noise of the detectors themselves. Yet scientists still tease out meaning from them. The future is short in human terms. Perhaps only a few more years of power remain. But when their voices finally fade, the Voyagers will continue their silent journey, drifting between the stars for millions of years. They will be monuments to exploration, carrying a golden record of Earth's sounds and stories, waiting for whoever, or whatever, might one day find them. It was meant to be our flawless window to the universe, until the first look came back blurry. In 1990, after years of anticipation and billions invested, the Hubble Space Telescope launched aboard the Space Shuttle Discovery. Astronomers dreamed of crystal-clear images that would revolutionize our understanding of the cosmos. But when the first pictures arrived, the world gasped, and not in wonder. The giant mirror had been ground incorrectly, by a fraction of a human hair, enough to distort every image. The headlines were merciless. Critics called it a $2 billion white elephant. NASA's reputation teetered. But behind the scenes, engineers refused to let Hubble die. They devised CoStar, a corrective optics system, essentially glasses for the telescope, to redirect light and fix the flaw. In 1993, astronauts embarked on a daring 5-day series of spacewalks to install CoStar, upgrade computers, and give Hubble a second chance. The tension was electric. And then, the moment of truth. The first corrected image appeared on the monitor. Sharp, brilliant, perfect. Around the world, scientists cheered. Hubble was reborn. From that day, Hubble became a legend. It revealed galaxies colliding, nebulae blooming, and the deep field images that showed thousands of galaxies in a patch of sky no bigger than a grain of sand held at arm's length. It was only supposed to last 15 years, yet it kept delivering for more than 3 decades. Then, in 2021, disaster struck again. A computer failure silenced Hubble. the anomaly response team, led by veterans and even retired engineers who had worked on Hubble decades earlier, raced to diagnose the problem. For 4 anxious weeks, the telescope lay dormant. Finally, on July 15th, the backup computer was powered up, instruments came back online, and Hubble returned to science. Today, Hubble is more than a machine. It's a survivor, a teacher, and a symbol of human persistence. Astronomers call themselves Hubble huggers, because once you've fought to save something that shows you the universe in all its glory, you never let go. It was a mission that dared to do what no one had ever attempted, to catch a comet racing through space and land upon it. Rosetta was more than a spacecraft. It was a time machine built to travel back to the earliest days of the solar system. Inside, tucked away like a precious secret, was the Philae lander, a tiny explorer destined for one of the most dangerous landings in history. The journey began in 2004, with a launch that set Rosetta on a 10-year chase across the solar system. To save fuel, it slingshotted around Earth and Mars, drifting into deep space hibernation for years. When the wake-up signal was sent in 2014, the tension was unbearable. If Rosetta didn't respond, billions of euros and decades of work would vanish into silence. Then, a heartbeat across the void. Hello, Rosetta. The mission was alive. As Rosetta approached Comet 67P/Churyumov-Gerasimenko, the first images stunned the world. This was no smooth potato-shaped rock. It was a bizarre, rubber duck-shaped world, jagged and treacherous. Landing Philae would be far harder than anyone imagined. On November 12, 2014, Philae was released. For 7 long hours, it fell toward the comet's surface. In control rooms around the globe, scientists held their breath. The first touchdown brought cheers, but joy turned to shock. The harpoons meant to anchor Philae failed, and the lander bounced nearly a kilometer back into space before settling in a shadowed crevice. Shadow meant darkness, and darkness meant death for a solar-powered lander. With less than 72 hours of battery life, the team had to rewrite months of science plans in just 5 frantic hours. They pushed Philae to its limits, running experiments, drilling into the surface, and capturing data that would change comet science forever. Against all odds, 80% of the mission's science goals were achieved before Philae fell silent. The discoveries were extraordinary. Jets of gas and dust erupting from the comet's surface, a crust harder than expected, and, most tantalizing of all, organic molecules including glycine, an amino acid essential for life. These findings hinted that comets may have delivered the building blocks of life to Earth billions of years ago. Rosetta continued to orbit 67P for 2 more years, mapping its surface and watching it evolve as it neared the Sun. In 2016, in a final act of intimacy, Rosetta descended and crash-landed on the comet, sending back images until the very last second before its signal went dark. For the scientists who had lived with Rosetta and Philae for decades, it was like saying goodbye to dear friends. Tears flowed, champagne popped, and the world celebrated a mission that had rewritten our understanding of comets, the solar system, and perhaps even the origins of life itself. Rosetta and Philae proved that exploration is not just about reaching a destination. It's about daring to go where no one has gone, and embracing the unknown with open arms. Now it's your turn, space explorers. If you could hitch a ride on any of these legendary missions, James Webb's Golden Eye, Parker's Fiery Plunge, Voyager's Endless Journey, Hubble's Cosmic Window, or Rosetta's Comet Chase, which one would you choose and why? Share your answer in the comments below. Your pick might just spark a debate among fellow stargazers. And don't drift too far. Our next video will take you even deeper into the mysteries of the cosmos, with stories that will challenge what you thought you knew about space. Subscribe, stay tuned, and keep your eyes on the stars. The journey is only just beginning.